Welcome friends to my YouTube channel Sommo Physics. In today's topic I will going to discuss about an important issue which is sim pendulum. Okay, which is pendulum. Now we all know what is pendulum, that you will know from your higher secondary course, that it is a weight suspended from a pivot. It is a weight suspended from a pivot so that it can oscillate freely. Okay, this is the suspension, then this is the pivot, okay, from which the pendulum is suspended. Okay, it is a weight which is suspended from that pivot and so that it can oscillate freely. Okay, so it is a weight suspended from a pivot, suspended from a pivot so that it can oscillate freely. Okay, so this is the definition of a simple pendulum or a pendulum. Now here we consider the simple pendulum at first. Okay, so suppose this is O and this is A, and any instant the pendulum bob moves from this point to this, okay, that is B. At any instant the pendulum bob moves from A to B, and suppose that distance is x. Now join O and B, okay, and this is the angular displacement theta, and the length of the pendulum bob is L. And here must remember that theta, the angular displacement is very small. Angular displacement is very small, that is we take it less than 4 degree. Must remember this condition, that the angular displacement is very small and we take it less than 4 degree. So this, since this angle is very small, if it is L, it will also be L. And at any instant the bob moves from A to B by traveling the distance x. So current position of the bob is this. Okay, so first thing, if the bob is at B point, then at B point the weight of the bob is mg, and it can be resolved into two components, that we all know, that the pendulum bob can be resolved into two components. Okay, what are they? Now what are these two components? One is this and another is this. This is, if this is theta, this is also theta. So this is mg cos theta and this is mg sin theta. Okay, now we all know that mg cos theta balances the tension, okay, and mg sin theta tries to bring the pendulum bob into its original condition, that is at A. Okay, so mg cos theta balances the tension and mg sin theta tries to bring the bob into its original condition. Okay, so these are the functions. At B there are two components of mg. Mg cos theta balances the tension and mg sin theta tries to bring the pendulum bob into its original condition. Okay, so this is the restoring force, mg sin theta or minus mg sin theta. Okay, so since this is the restoring force, we can give it minus mg sin theta. Minus sign indicates that the force is restoring. Okay, now since theta is small, we can write mg theta. We can write theta instead of sin theta, because when theta is small, sin theta almost equal to theta and cos theta equal to 1. So from this what we get, theta perpendicular by base, that is x by L. we can write. Okay. Now due to the own motion of the pendulum, if m is the mass of the pendulum bob and we see x is the displacement, so what will be f? My f will be m into d2x dt2. This equals to minus m into g by l. You can write x. mm cancels. So what we get? d2x dt2 plus g upon l. This equals to x. So from which we can write d2x dt2 plus omega square x. This is equal to 0. Thus we see that the motion is simple harmonic. Okay. We see that the motion is simple harmonic. After solving the equation, we prove that the motion is simple harmonic. Now let us try to find out the angular frequency on oscillation and time period of oscillation. Okay. Let us try to find out the angular frequency of oscillation and time period of oscillation. So here we write omega, this is equal to g upon l whole to the power half. This is the angular frequency of oscillation. Now what will be my time period? 2 pi by omega, that is we can write 2 pi square root l by g. So this is the working formula. So from which we can draw the conclusion, or moreover we can see that this expression obeys the pendulum laws. What are? The time period of oscillation is directly proportional to the square root of the length. Okay. T is proportional to the square root of L. This is the first law of pendulum. We all know that if G remains constant and M remains constant, then the time period of oscillation is directly proportional to the square root of the length of the pendulum. Next thing, T is proportional to 1 upon root G. So if length of the pendulum and mass remains fixed, then time period of oscillation is inversely proportional to the square root of G. And clearly you can see in this expression there is no mass. So T is independent of mass of the bob. So what are they? They are laws of simple pendulum. Laws of simple pendulum. Okay. Again, when G is fixed, T is proportional to square root of L, and when L is fixed, T is inversely proportional to square root of G, and it is independent of the mass of the pendulum bob. Thus we see that the motion of a simple pendulum is a simple harmonic, and we also find the angular frequency of oscillation and time period of oscillation, and from which we can clearly see that these expressions obey the pendulum laws. Okay, so this is about simple pendulum. Now we have to discuss few important uses of simple pendulum. Okay, before I move on, dear guys, if you don't subscribe my channel, then kindly subscribe it and share it to your neighbors, friends or relatives to get latest updated videos on higher secondary and BSc physics. Okay, so let us move. Now what are the basic uses of simple pendulum? Now the first use of simple pendulum is that we can determine the acceleration due to gravity of any particular place. How? From pendulum law we get T equals to 2 pi root L by G. So if you take square, what we get? T square, this is equal to 4 pi square L by G. So from which we can easily tell G, this is equals to 2 pi by T whole square into L. So knowing all the quantities in right hand side, G can be determined. Okay, so G can be determined. So this is one use, that acceleration due to gravity of any place can be determined. Okay, this is the first use. And again, we can also find the height of a place by using simple pendulum. How? Let us check how we can find the height of any particular place by using simple pendulum. Now we all know that acceleration due to gravity at Earth's surface, this equals to gm by r square, and that at a height h, this is gm by r plus h whole square. So what will be my gh by g? My gh by g will be r square plus r plus h whole square. So give it a name 1. Now if t and t dash, these are the time periods corresponds to acceleration due to gravity g and gh, that is g is the acceleration due to gravity when time period of oscillation is t, and gh will be the acceleration due to gravity when time period is t dash. So what will be my t? Using pendulum formula we can write 2 pi root l by g, and what will be my t dash? Twice pi square root l by gh. So what will be my t by t dash? My t by t dash will be square root of gh by g. Okay, square root of gh by g. Okay, so this we can do. So if we substitute these values in equation 1, so here gh by g and here square root of gh by g. Okay, so gh by g means t square by t dash square. This is equals to r square by r plus h whole square. So we can clearly write t dash by t, this equals to r plus h by r. That means 1 plus h by r. Okay. So what will be my h by r? My h by r will be t dash minus t by t. So what will be my h? My h will be r upon t, t dash minus t. So this is the working formula. By knowing all the quantities of right hand side, we can easily find the height of a particular place. Thus we see in today's lecture that simple pendulum can be used to determine the acceleration of gravity of a particular place. Okay, and we can also find out the height of a particular place by using time period of oscillation and relate it with g, compare it with g. So these are the today's lecture where we have discussed about simple pendulum and their few uses. Okay, so in our next class I will discuss about few applications of gravitational potential, and there I will consider at least 2 examples. I will take spherical shell and solid sphere. Okay, so this is what about today. Okay, thank you.